Alright, hi guys. So today we're going to be solving this question. Now, when it comes to questions like this, switch open, switch close, the thing is, first of all, you have to understand whether you're solving a source free or not a source free circuit. So the switch has been closed for a really long time, and then at t equals 0, the switch is what's opened. And they wanted to find v of t at t greater or equals to 0. This just means as time has gone on, after they opened the switch, we want you to find v of t. Now the formula for that V of t that I'll be using will be equals to V naught E raised power t over tau. Why? After this thing is disconnected at t equals to 0 now, it is this capacitor that begin to act as the battery for the circuit, as the source for the circuit. Because when the battery was connected, it charged up, and then after the battery was disconnected, it will start discharging. And so therefore the V of t is very dependent on whatever voltage the capacitor has. So this V naught actually, that's the initial voltage in the circuit after the switch has been disconnected, is actually the voltage in the capacitor. I hope you understand that. Now, but first of all, to get extra mark, because I didn't understand this topic before, to get extra mark, I always just solve for tau first. So tau is REC times C, that's capacitor. To find REQ, you always evaluate REQ after the switch has been opened. Take note of that. So after the switch has been opened, guess what? The entirety of the circuit gets condemned because if current tries to go here now, it's stuck here. This entire circuit cannot conduct any form of current. It's condemned. So it just becomes this. This becomes the circuit. So this is just it. And REQ, I think it's obvious they're in series. So it's 1 plus 9, which equals to 10 ohms. And then C is 20 mF. So if you multiply the both of them, it's going to give you 0.2 seconds. Now remember, I've explained to you that this V naught is the initial voltage that the capacitor had in the circuit after the switch was disconnected. So to find that this initial voltage, right, you have to actually calculate it with the switch closed. I'll explain that shortly. But you see, capacitor acts as an open circuit when it's connected to a DC source. So this has to become an open circuit. And then we're just trying to find the voltage here. That's the initial voltage. So basically now, if we can find this, we know what voltage the capacitor will have in itself before the switch will be open at this point. Now, open circuits affect whatever is in series with them. So in this case, you can see that this 1 ohms is in series with it. So it affects it. It basically makes this useless because think about it. If current comes here, the current will just hang here. The only place current can actually loop through is just here. So this particular circuit is condemned. Therefore, they just see it as there's no 1 ohms resistor there. Just see it like as a straight line. So to get VC, I know that voltage in parallel circuits should be the same. So the voltage here and here should be the same as the voltage here and here. So I'm simply going to use voltage divider rule to get the voltage across these 9 ohms. It's going to be 9 over 3 plus 9 times 20 volts. This is because voltage drop here, voltage drop here. That's why I can use VDR. So in that case, the voltage will be 15 volts. That means this capacitor before the switch was open had a voltage of 15 volts. So now I can simply substitute it into the equation. 15 E raised power minus T. What was our tau? 0.2 volts. Now why is it E raised power negative? Go on and just check E raised power negative 2 graph or something like that. You see it's going downwards like this because as soon as you disconnect the battery, and the capacitor will start to discharge this 15 volts, it comes 14.9, 14.8, it start to discharge, it start to go down. That is why this exponential raised power negative is used to model it. Now to calculate the initial energy stored in the capacitor, It simply be this just initial energy. Zero just means initial. Half C, that's capacitor, V square C. That is the voltage in the capacitor initially. They're going to basically be half 20 mF times 15 square, which is going to be equal to 2.25 joules. So this is your final answer. I really hope you understood what I explained. Thank you for listening.